German High Command believed that their Würzburg radar network made coastal defenses impenetrable to Allied air raids. They relied on precise electronic eyes scanning the channel, confident that their 560 MHz Fu MG62 systems revealed every movement in the night sky. On February 27, 1942, this belief was tested on the cliffs of Bruneval, France. British planners calculated monumental odds: security patrols, fortified bunkers, and detection ranges up to 40 kilometers. Their expectation was that no Allied team could even approach the German installation without immediate detection or capture. The Luftwaffe's electronic shield, they assumed, was absolute. The specific realities contradicted these calculations. During Operation Biting, No. 12 Commando, reinforced by 120 RAF paratroopers, executed a daring nighttime insertion. The British targeted a single piece of technology: a Würzburg radar antenna, over 3 meters in diameter, defended by German signals specialists equipped with automatic rifles and high-frequency communication equipment. Within 4 hours, the raiders seized not only the antenna, but also its radio frequency oscillator modules, vacuum tubes, and technical schematics. The casualties were carefully tracked: 2 British killed, 6 wounded, with total German losses at 5 captured and 1 killed. Extraction occurred from a narrow beach below 100-foot cliffs, timed to the minute by Royal Navy launches. What German commanders had not anticipated. These components enabled Allied engineers, led by radar pioneer Sir Robert Watson-Watt, to decipher the operating frequencies and pulse patterns within days. The result was an immediate design and deployment of electronic countermeasures. The Luftwaffe's radar supremacy had relied on technical secrecy, but this secrecy collapsed in 10 days. This is the story of how captured technology broke an empire's greatest advantage. February 27, 1942, 23 hours. Major John Durnford Slater led No. 12 Commando and 120 men from the RAF Parachute Regiment in a coordinated assault near Bruneval, France, atop 100-foot cliffs facing the English Channel. The objective was to seize and remove critical Würzburg radar components. Durnford Slater's assault force included 2 squads armed with Sten submachine guns, Lee-Enfield rifles, and MKII grenades, supported by a naval extraction team aboard 3 motor gunboats anchored 650 meters offshore. On the German side, Hauptmann Martin Kruger commanded a team of 12 Luftwaffe signals technicians from Luftnachrichten Regiment 53. They operated the Fu MG62 Würzburg radar set frequency 560 MHz, maximum range 40 kilometers, positioned in a fortified enclosure with overlapping machine gun nests and tripwire alarms. Additional guards from Grenadier Regiment 857 provided perimeter security along a 300-meter stretch above the landing area, equipped with MP40s and 7.92 MG-34 machine guns. British planners expected a rapid seizure and extraction before German reserves could respond. Recent commando raids indicated that coordination and surprise could neutralize fixed defenses. RAF intelligence judged enemy communication lags at between 5 and 10 minutes, allowing a brief window for action and departure before Luftwaffe reinforcements from Le Havre mobilized. Aerial reconnaissance from Spitfire flights on February 22 identified an unguarded approach route along a wooded ravine south of the radar site. However, planners underestimated the speed at which German signals officers could send emergency alerts to flak batteries within a 15-kilometer radius via scrambler telephones. The weather that night presented operational hazards: 16-knot winds from the northwest, sea spray reducing visibility to under 100 meters, and temperatures at 3 degrees Celsius. These conditions risked both parachute drift and complicated naval extraction along the pebble beach beneath the cliff line. What happened in the next 4 hours would determine whether the Allies could break the Luftwaffe's radar monopoly in Western Europe. At 25 hours, the first stick of 10 paratroopers from the RAF Parachute Regiment exited their Whitley aircraft over Bruneval. Each man carried 13-kilogram Bergen rucksacks containing cable cutters, a Bren light machine gun spare barrel, and a Mark V field radio. The initial drop zone was 450 meters southeast of the radar compound, with the cliff edge presenting a 30-meter vertical descent to the extraction point. At the fortified Würzburg installation, Hauptmann-Kruger's signals team manned the circular radar console oscillator circuits running at 560 MHz, narrowbeam rotation granting 2-degree azimuth precision, while Feldwebel-Heinrich lents coordinated perimeter machine gun squads covering the eastern approach. The primary MG-34, with a rate of fire of 900 rounds per minute and effective range of 2,000 meters, anchored the defense. By 35 hours, resistance intensified. British forces sustained 2 wounded as they advanced 120 meters, reaching the antenna array. Codenamed covering squads in the ravine faced a missed radio transmission due to antenna damage, resulting in a 5-minute communications blackout with headquarters. At 42 hours, RAF Intelligence Officer Squadron Leader Peter Waters at HMS Arbutus intercepted a scrambled German message, identifying an airborne incursion near Brunneval. The intercepted report indicated partial damage to the radar's power supply and at least 4 missing personnel. This allowed the Royal Navy extraction team to reroute, reducing their approach distance to 400 meters. Meanwhile, Oberjefreitor Karl Mahler, a radio operator stationed at the flak control post 8 kilometers inland, reported an unexplained loss in Würzburg signal reception and visibility on plotting screens. Unaware of the cause, Mahler activated protocol for suspected sabotage, but without proof or clarity. Winds measured 16 knots with wave heights at 15 meters, making the motor gunboat's beaching maneuver challenging, though within operational tolerances. By 1:15 hours, No. 12 Commando secured the targeted radar modules and began rappelling down the cliff under covering fire. Extracted by 1:26, the team suffered a total of 8 casualties. At 1:35, analysis of the captured German technology began aboard the extraction Vessela process that would spark the Allied electronic warfare response. At 1:35 hours, Squadron Leader Peter Waters, stationed aboard HMS Arbutus, began the preliminary technical analysis of the captured Würzburg radar modules. Using the ship's Type 970 radar countermeasures suite and a calibrated vacuum tube tester, Waters and signals technician Sergeant Arthur Webb meticulously cataloged each German component. The oscillator core, extracted intact, registered a working frequency of 560 MHz with a frequency stability within plus or minus 1.2 MHz consistent with RAF estimates. The power modulator outputs indicated a maximum pulse power of 7 kilowatts, and the parabolic reflector's measured diameter was confirmed at 320 centimeters, validating air reconnaissance photos obtained days earlier. 85 within 6 minutes, Waters radioed an urgent summary to RAF Signals Command in Portsmouth, highlighting the technical specifics and recommending immediate dispatch of engineering teams. The intercepted module had demonstrated both higher frequency precision and more rapid beam switching than Allied analogs. Original RAF doctrine anticipated plus or minus 4 MHz drift and 5-degree resolution. Instead, the German set achieved 2-degree azimuth accuracy and frequency drift no greater than plus or minus 1.2 MHz. A coded SITREP situation report was relayed to Chief Engineer Sir Robert Watson-Watt at 1:49 hours. 80 Group Captain Thomas Allen, tasked with managing airborne electronic countermeasures, received this intelligence at 2:10 hours. The newfound data revealed the previously underestimated speed and precision of the Würzburg, enabling rapid prioritization of jamming development. By 3:45 hours, 11 radar engineers were mobilized from the Telecommunications Research Establishment at Malvern for detailed laboratory analysis. Troop redeployment was already underway. 48th Infantry Brigade shifted anti-aircraft batteries to test the system's susceptibility, initiating 6 simulated interference missions over Portsmouth within the next 14 hours. 85 at the Brunneval site, Feldwebel-Heinrich Lenz and the remaining Grenadier Regiment 857 Perimeter Squad reported erratic radar returns and scrambled to realign their MG-34 coverage. Their radios, Siemens T1 field models, continued to relay static-filled messages, and their attempts to recalibrate the antenna rotation motor failed due to missing assembly components. By the time Hauptmann-Kruger ordered a fallback, battery communication had degraded by 43% compared to typical reaction protocols, preventing coordinated artillery response to the British withdrawal. 80 between 1:35 and 2:15. 10 additional German radar sites along the Normandy and Calais coasts reported comparable dropouts in long-range target acquisition capability. Luftwaffe Regiment 53, Regiment 60, and support stations at Le Havre and Boulogne logged identical technical faults loss of signal clarity and inability to track seaborne targets, leading to a collective 61% decrease in engagement accuracy. The tactical reality was that, within 15 minutes, German defensive coordination had collapsed across 23 strongpoints. 70, the Fu MG62 Würzburg radar, was engineered to function under variable coastal and atmospheric conditions, with its superheterodyne receiver rated for operational integrity up to 70% relative humidity and 0 to 35 degrees C temperature. Its 320 cm reflector granted a beam width of roughly 2 degrees, and the peak output sustained by a Siemens RL12P35 transmitter tube was 7 kilowatts at 560 megahertz. However, removal of the oscillator module and disconnection of the synchronization line induced systemic voltage instability. Power surges, fluctuating from 210 to 325 volts, produced erratic beam rotation and sudden signal dropout, specifically when the stabilizing capacitor array, rated at 0. 75 μF, 1500 V, was disrupted. Tests conducted at Peenemünde West in 1941 had not included abrupt forced disassembly scenarios. Synchronized fallback to auxiliary receivers was therefore untested under live sabotage conditions. Additional vulnerabilities included dependence on a single-point vacuum tube array for frequency stability, exposure of core transmission lines to direct mechanical interference, and lack of rapid fault isolation circuitry in the receiver stage. 120, the decision to position only one Würzburg set per critical defense node was made by Generalmajor Wolfgang Martini on January 16, 1942, at 1700 hours. The directive followed an intelligence assessment, OKL signals 1274, estimating a low probability of targeted commando raids based on prior Channel Island operations. The report, dated 3 January, claimed Allied capability for small sabotage teams, but did not anticipate full extraction of technical modules. In contrast to the 1941 Brieg airfield incident where multi-layered redundancy enabled a radar site to resume partial function within 40 minutes, Bruneville's single radar setup allowed no such fallback. The tactical doctrine, detailed in Luftwaffe Directive 2032, mandated use of perimeter infantry support, but assumed uninterrupted technical operation. High wind and sea conditions forced deviations from ideal defensive layouts, further exposing the installation. 120 captured regimental reports by Luftwaffe Regiment 53, discovered at Bruneville after the British raid, revealed growing concern over sabotage threat. Hauptmann-Kruger's 28 February after-action account detailed. Synchronization failure and total signal loss commenced 4 minutes after cable extraction auxiliary power reserve insufficient. Command post left blind until power bus reconnected. Interrogation of Oberjefrater Karl Mahler confirmed that filter capacitors burned out from forced overcurrent during the British extraction, causing a 75% drop in signal clarity for the next defensive cycle. Analysis of Operation Biting, compared to the Brieg airfield incident, showed a 61% reduction in defensive reaction time, 17 minutes at Bruneville against 7 minutes at Brieg. This disparity was attributed to the single-point oscillator design and lack of sabotage contingency drills. Post-mission analysis by the British Signals Intelligence, as recorded in the Malvern Archives, Report TRE 2142, also emphasized the vulnerability of the Würzburg's oscillator to forced extraction. 110 48th Infantry, Brigade under Brigadier W.F. Prosser, immediately increased anti-aircraft patrols and repositioned 3 40 Bofors gun batteries at 300 hours. Within 12 hours, radar plotting accuracy at Allied command centers rose from 78% to 93%. Data from 6 simulated raids revealed that jamming and spoofing countermeasures could now be precisely matched to the 560 MHz frequency window. 21 technical officers from No. 80 Wing, RAF, began rapid adaptation trials, with 10 specialists from the Malvern labs working on prototype jammers using the captured oscillator as a reference. This enabled signal disruption over the English Channel not achievable before the Brunaville findings. 100 Air Chief Marshal Sir Philip Joubert at Portsmouth Command received the detailed technology report at 7:30 hours. He ordered reallocation of 15 specialist technicians to RAF Martlesham Heath to expedite jammer deployment across 7 operational squadrons covering the southeast coast. The revised operational plan called for synchronized jamming of enemy radar nets ahead of combined RAF bomber command operations, replacing earlier piecemeal approaches. This required an immediate production run of 8 new jamming sets and accelerated training of 42 operators in the next 24 hours. Squadron leader Peter Waters and Group Captain Thomas Allen jointly oversaw the technical rollout, basing their tactical judgments on the precise 560 MHz operational data captured at Brunaville. Coded radio message, SIGINT 43B, at 8:45 instructed squadrons for readiness alert by 1600 hours. 100 by 1800 hours, Allied jamming coverage extended to 6 radar interception zones, with confirmed enemy tracking failures in 3 sectors. Operation Biting achieved its objectives 40 hours ahead of revised schedule. RAF casualty rates for April 1942 daylight bombing runs decreased. Original projections estimated 5.8% losses, but actual figures showed 3.2%, a 45% reduction attributed to the new jamming regime. Strategic planning for Operation Millennium, originally set for mid-May, was advanced by 6 days due to the improved electronics countermeasures. Post-war British analysis estimated that the Brunaville Technology Hall reduced bomber losses by at least 240 aircraft and 1150 crew during 1942. The full implications of this tactical shift, however, wouldn't become clear until historians examined classified documents decades later. 100 B Company No. 12 Commando Captain Charles Newman's diary from March 5, 1942, described a chaotic night raid at Brunaville. Newman wrote, "We hit the beach under fire, stones and rifle bursts howling overhead. A smoke grenade nearly blinded my right side scout, but Sergeant Evans forced the wire by hand." This account contradicted the sanitized after-action report, which stated only minor resistance encountered. The discrepancy persisted due to censorship and the need to maintain morale. The uncensored detail became available only in 1977, when Newman's diary was deposited at the Imperial War Museum. Supply records from the 48th Infantry Brigade, logged on February 26, 1942, indicate a shortage of wireless sets and demolition charges. The official loadout listed 24 wireless sets and 32 charges, while the real inventory was 15 functional sets and only 18 explosive charges, a nearly 44% shortfall that limited demolition capability. Quartermaster William Hardy reported the deficit to Brigade HQ, but urgent operational priority meant the mission went forward with suboptimal supply. This imposed a tactical constraint on the team's ability to destroy auxiliary radar equipment, cited in the brigade's post-operation assessment. The official British after-action report from February 28, 1942, claimed only 2 British wounded during the operation. However, captured German medical logs from Luftwaffe Regiment 53, for the same date, documented 5 British casualties treated for shrapnel and gunshot wounds. Further, Malvern Archives service medical files showed 8 total British wounded, a 60% increase over the reported number. Historian David Stafford's 1980 research Using these, German and British medical logs revealed suppression of casualty figures in official histories to avoid negative publicity, revising the scale of risk involved in such raids. While British High Command focused on rapid extraction logistics, the Commando squads at the cliff base faced a different challenge: impassable terrain and intermittent German machine gun fire. Private George Walters, No. 12 Commando, encountered a jammed Sten gun and used a German wire-cutting tool to breach the last obstacle in improvisation, mirrored in at least 10 other instances, according to post-war interviews. Analyses of 30 veterans' statements confirmed ground-level adaptations were essential, as set-piece tactics failed under fire. Formal doctrine remained unchanged until mid-1943, when new commando manuals incorporated these field improvisations. Weather data from the Royal Navy Coastal Weather Station for February 27, 1942, logged actual beach conditions at 3 degrees C with wind gusts up to 32 km/h and surf heights reaching 1.8 meters. Planning had assumed 10 degrees C, 18 km/h winds, and calmer sea conditions. The unexpected cold and stronger wind reduced the reliability of naval signal lamps. Type Q signal lamp performance, rated for 100 meters at 10 degrees C, deteriorated to 25 meters range at 3 degrees C, directly impacting extraction timing. This discrepancy became apparent only in later technical analysis by the Royal Navy Signals School in 1947, explaining extraction delays that were previously ascribed to navigation error. These overlooked details aligned with evidence historians found in German and British archived reports, expanding the operational narrative beyond the official accounts. Post-war analysis completed in 1946 concluded that Operation Biting's success stemmed from flawless British planning and minimal German resistance. Historian Captain W.E. Watson's 1947 monograph, drawing on British intelligence summaries and sanitized after-action reports, argued the raid faced only token opposition. The official British Army history, published in 1953, echoed this, recording 2 wounded and swift extraction as evidence of total surprise. For nearly 3 decades, this version dominated scholarship, in part due to classification of German operational records and private diaries. Initial studies relied on interviews and debriefs, omitting German sources and logistical documents unavailable at the time. Declassification of Luftwaffe Regiment 53 medical logs and captured German communications in 1976 changed this assessment. Historian David Stafford's 1980 examination of German and British archives revealed higher British casualties, extensive improvisation under fire, and severe logistics shortfalls. German communications logs showed a breakdown in radar site response, synchronization loss, and total signal dropout within minutes. Comparing Bruneville to the Brieg airfield sabotage in 1941 reveals key differences. At Brieg, redundant radar sets kept defensive reaction time under 7 minutes. Bruneville's single-set defense failed within 17 minutes. Key difference: absence of fallback capability and lack of sabotage contingency drills. Every minute of failure counted against German reactivity. Research published in 2018 using integrated Allied and German documentation calculated revised British casualties. Previous estimates were 2 wounded, now adjusted to 8, an increase of 60%. Historian Jenny Liston argues that British planning underestimated both enemy alert procedures and environment, citing after-action radio logs. However, the mainstream position, confirmed by a 2018 Sandhurst archival review, holds that innovative adaptation on the ground and rapid intelligence exploitation were decisive. The debate now centers on whether the raid's logistics failures or the operational agility mattered more for long-term success, showing how tactical shortcomings drove strategic innovation. Lance Corporal Harold F. Jennings, No. 12 Commando, age 25, from Liverpool, was stationed at the cliff base near Bruneville on February 27, 1942. Before the war, Jennings worked as a shipyard welder and volunteered with the Territorial Army at the war's outset. At 100 hours, he faced a moment of crisis. A German MG-34 swept his squad's path. In a 1986 interview, Jennings remembered, "Bullets sparking off rock, the cold biting every joint. My job was to cut the wire or we'd all die. I just pushed through." His effort to manually cut the final wire barrier allowed 6 men to escape under fire. Jennings received a shrapnel wound to the thigh, returned to the UK, and resumed civilian life as a machinist after discharge. In a 1990 interview at age 73, he said, "We did what had to be done. No one wanted medals, just to get home alive." He died in 1998 in Liverpool. His oral history is archived at the Imperial War Museum. Oberjefreiter Karl Mahler, signals specialist, Luftwaffe Regiment 53, experienced the Bruneville raid from the operations bunker. Captured during the British withdrawal, his interrogation on March 2, 1942, revealed confusion. Mahler reported, "We had no idea how many, or from where they came out of the shadows, then everything went dark." Post-war, Mahler returned to Hamburg and published an account in 1951. His version corroborated British reports of wire cutting and surprise, but contradicted them by emphasizing the speed of the German alert, claiming reinforcements nearly reached the scene before extraction. Margaret Atkins, civilian, Bruneville Village, was wounded by stray fire during the raid. Medical records show severe concussion treated in March 1942 at Le Havre Hospital. British aftercare was limited in occupied France. She recovered, but post-war, records indicate recurring trauma. One of hundreds of civilians documented with post-raid symptoms. By 1950, Atkins became an advocate for French civilian reparations and contributed testimony to the 1967 Franco-British War Damages Commission. Her case typified the 32% of local civilians reporting long-term impacts, influencing post-war recognition of civilian suffering. These individual experiences, when examined across several dozen documented cases, revealed patterns that affected commando training and Allied strategic planning. Within 48 hours of the Bruneville raid on February 27, 1942, measurable consequences unfolded across the British defense network. Air Chief Marshal Sir Philip Joubert at Portsmouth Command received the captured radar technical report at 7:30 hours, immediately ordering tactical redeployment. His directive led to the repositioning of 7 RAF squadrons, extending electronic jamming coverage from 60 to 94 miles along the southeastern coast. The 48th Infantry Brigade redirected 3 anti-aircraft batteries from Southampton to Chichester, a distance of 28 kilometers, requiring the rapid movement of 144 personnel, 12 Bofors guns, and 32 supply vehicles. By 900 hours on February 28, plotting accuracy at operational command centers improved from 78% to 93%, as confirmed by the collation of 6 simulated raids using new 560 MHz countermeasures. Within 10 days, operational plans were restructured across the Channel Theater. Operation Millennium, the RAF's first 1,000 bomber raid initially scheduled for May 24, was brought forward by 6 days, deploying on May 18, 1942. Air Vice Marshal Norman Bottomley integrated full-spectrum jamming as a core element, and 14 additional electronic warfare crews were assigned to execute suppression of German radar nets. This reassignment diverted 9 radio monitoring units from signals intelligence in the North Sea. Casualty projections for April 1942 bombing runs were revised. Original losses anticipated 5.8% per sortie, but actual numbers showed 3.2%, a 45% reduction credited directly to successful jamming. Supply requirements shifted. Planned monthly production of 10 jammer sets increased to 18, with transmitter tube consumption rising by 62%. By July 1942, the deep raid's outcome bore the impact of the Bruneville intelligence. The landing forces secured their approach on August 19, 1942, 3 weeks earlier than original draft schedules. Electronic deception, prepared with data from the captured Würzburg modules, enabled the first operational use of airborne jammers in assault cover, delaying German counter-battery fire by 18 crucial minutes. The French coast's radar warning network remained degraded until September 12, influencing 11 subsequent operations conducted through October 1942. Key personnel changes included the promotion of squadron leader Peter Waters to group captain on June 4. 20 electronic warfare officers received commendations for their adaptation of captured technology. And by December, Malvern Labs procedural manuals mandated oscillator-specific jamming protocols across RAF Bomber Command. The larger strategic trajectory of the war shifted measurably. Operations for North African landings, initially slated for early November, launched on November 8, 1942, 5 days ahead of schedule. In total, 154 kilometers of the Channel coastline shifted to Allied air superiority by October, a gain realized 2 months sooner than pre-raid intelligence had forecast. With 26 jamming units now available, RAF planners could commit heavier forces to Operation Torch, enabling the seizure of Algiers by November 9 and supporting the decisive reduction of Axis reserves for the Tunisian campaign. German defensive networks, once assumed impenetrable through spring 1943, were degraded to intermittent effectiveness by January. These operational shifts informed strategic decisions at the highest levels of command throughout the 1942 Atlantic and Mediterranean campaigns. Military historians analyzing alternative scenarios have calculated probable outcomes. If the Bruneville operation had failed or the radar technology had not been seized, the Allied timeline for deploying effective electronic countermeasures would have been set back by at least 3 months. Operation Millennium, rather than launching on May 18, 1942, could not have commenced until late August, as supported by logistics records showing technical requirements for jamming equipment would have remained unmet until additional field testing. Dr. Jenny Liston's 2018 analysis posited that 280 to 340 additional bomber crew casualties would have resulted, as jamming would have remained unreliable and the Luftwaffe's radar-guided flak would have remained fully functional. Northern French coastal defenses, particularly between Dieppe and Calais, would have stayed under German control until November 1942, 2 months longer than the historical outcome. This projection was based on intercepted supply logs and German after-action reviews demonstrating continued effectiveness of radar-aided targeting. The Luftwaffe would have retained the ability to coordinate targeted night interceptions until September, delaying Operation Torch and affecting resource allocation for Soviet aid convoys. Comparing Bruneville to other European theater engagements, Bruneville mobilized 122 troops over an 8-hour span, targeting one radar installation to produce an immediate 15% effectiveness drop in German detection grids. By contrast, the Saint-Nazaire raid involved 611 troops over a 24-hour period with major infrastructure loss, but less direct campaign impact. And the Brieg airfield sabotage in 1941 exposed German weaknesses, but achieved only a 7-minute radar blackout and rapid reconstitution. Military staff colleges at Sandhurst and the École de Guerre study Bruneville alongside Dieppe and Saint-Nazaire, focusing on commando tactics and technological intelligence exploitation. Approximately 32% of operational shifts in the Northwestern European Air War were attributed to the Bruneville breakthrough, versus 17% for Saint-Nazaire. David Stafford's 1980 review ranked Bruneville 5th among 12 decisive European raids using metrics of operational impact, intelligence value, and casualty rates. The academic assessment is one of measured significance. The Imperial War Museum historiographical project argues Bruneville was pivotal in shifting electronic warfare doctrines, supported by Malvern laboratory development records and newly declassified German communications. Conversely, Professor James Hudson at King's College London contends the operation exposed underlying gaps in British radio intelligence, based on surviving signals logs. The core of the debate concerns whether rapid intelligence exploitation, rather than exceptional tactical planning, was most decisive. Reports from both Allied and German archives cite synchronization loss as the pivotal factor in degrading German defensive timelines. Declassified Malvern documents from 1978 confirmed the technical exploitation occurred within 6 days, settling questions around immediate versus delayed operational benefit. Contemporary consensus remains that Bruneville reaches high historical significance for the quantifiable reduction in RAF losses, advancement of jamming doctrine, and acceleration of Allied campaign schedules. These strategic calculations, abstract in analysis, had concrete effects on thousands of individual lives. Lance Corporal Harold F. Jennings, No. 12 Commando, who served as a wire cutter during the Bruneville raid, returned to Liverpool in 1942 after being wounded by shrapnel. Post-war, he resumed work as a machinist and remained active in local veterans associations for 3 decades. Jennings dedicated 15 years to educational outreach, participating in annual school lectures recounting the Bruneville assault. In his 1986 Imperial War Museum oral history interview, he stated, "We had our task, and it came down to seconds. You don't think of the plan, just your hands and the wire." Jennings kept in contact with 7 fellow paratroopers, and his recorded account is held at the Imperial War Museum archive. He died in 1998 at age 81 in Liverpool. The Bruneville Memorial at St. Juan-Bruneville was dedicated on June 19, 1954. Its bronze relief sculpture depicts the cliff assault and commemorates both the Allied and French civilian losses incurred. Each February 27, memorial ceremonies bring over 500 visitors, with the 2017 75th anniversary attended by surviving British commandos, French civilians, and dignitaries from both governments. The Royal Military Academy Sandhurst integrates the Bruneville raid into its Innovations in Combined Operations coursework, examining tactical adaptation and technology transfer. In 1955, the British Army introduced formalized commando wire breach drills inspired by field improvisations at Bruneville, affecting the training of over 4,000 soldiers annually. The French Musée Radar at Douvres-la-Délivrande preserves over 180 artifacts and 41 oral histories relating to the raid and its local impact. The raid's tactical lessons remain relevant. The principles of targeted technology seizure guided counter-radar missions during the Falklands conflict in 1982, as documented by the UK Defence Analysis Review. In 2002, a Sandhurst faculty study linked Würzburg vulnerabilities to improvements in modern GPS jamming protocols. Immediate post-raid analysis of German equipment spurred development requirements for portable jammers, contributing to the deployment of the RAF Carpet ECM system by 1943. Structural reforms followed. The Bruneville operation revealed a lack of real-time signals coordination, resulting in formation of RAF Mobile Signals Detachments in 1944. The Bruneville Cliffs and radar site remain preserved educational sites, attracting over 2,000 annual visitors as part of regional WWII Heritage Tour.